Okay, we'll look at the homework problems that are in section 10.3, which is part 2 of displaying data. This talks about broken line graphs and also scatter plots, and also talks about the trend line and also whether you have a positive, negative, or no particular association based on a scatter plot. Problem number 1 is this. The graph shows how the value of a car depreciates each year. This graph helps define the trade-in value of a car for each of 5 years. The percents are given in the graph. The percents given in the graph are based on the selling price of the new car. And you're going to complete parts A through D below. So the vertical axis is your percentage of the selling price and the horizontal axis is the year. In part A, what is the approximate trade-in value of a $14,000 car after 1 year? Okay, now let's look at this one. We have 1 year, and here, this dot is at this particular place, and it's past 60. It's between 60 and 80, so we're going to say it's halfway between 60 and 80, so that means this is 70%, because this is sectioned off into like this: 60%, then 65, 70, 75%, then 80. That dot is at 70%. So here we're going to take 70% of $140,000, which is in this case 0.70 when you change it to a decimal. And the word of means you're going to have to multiply $140,000. And when you do that, your answer is going to be $9,800. That's going to be the approximate trade-in value of that $14,000 vehicle after 1 year. $9,800. Just simply take 70% of $140,000. How much, part B is this, how much of a $15,000 car depreciated after 3 years? So here's 3 years right here, and here's the dot at 3 years. So here we're going to find out what that percentage is going to be. Okay, so that's 40% after 3 years. So the car is going to be depreciating at 40%. So the trade-in value is 40% of $15,000. Or we can do 0.40 times 15,000, which will give you $6,000. So we know the trade-in value is $6,000. But they asked how much has the car depreciated after 3 years. So we have to subtract the cost of the vehicle, which is $15,000, minus the trade-in value of $6,000. And that would give us $9,000. So after 3 years, that car has depreciated at $9,000. Okay, using this graph, we're going to look at part C. What's the approximate trading value of a $10,000 car after 5 years? Here's your 5. And in this case here, that dot, if you look at it, is halfway between 20 and 40, which is going to be 30%. So the percent of the selling price is going to be 30% of $10,000, which is 0.30 as a decimal times 10,000. And that would give you $3,000. So here, the trade-in value for that $10,000 car after 5 years will be just $3,000. Okay, and then part D is this. Danny wants to trade in her car before it loses half of its value. When should she do this? Okay, so now, so she wants to sell the car before it loses 50% of that value. So 50%, if you look at the graph, is halfway between 40 and 60. That's about right here that I'm marking off. So here, if I draw a line, a horizontal line at 50%, you can see here that if she doesn't want to, if she wants to sell the car before it loses half of its value, which is 50%, that means she needs to sell that car before the third year because it's going to reach 50% between the second and the third year. So before the third year, she should do this. So actually, it's going to be around the second year she needs to do this. She needs to sell, she needs to trade in the car before it loses half the value. Okay. Okay, so that's going to be problem number one, just reading a broken line, a line graph to answer those types of questions. Okay, problem number two is a couple of broken line graphs. And here, the graph at the right shows the number of snow shovels sold in winter months at a store in 2010 and 2011. And what I'm going to do here is draw in a red line to indicate that this line represents 2010. So that way you can see the difference between those two. Now to answer A, B, and C, we have, during which months did the store sell the most snow shovels in 2011? Okay, in 2011, so that's this black broken line right here. As you can see, the most was sold in January. So in 2011, the most snow shovels were sold in January. So that right there is part A. Okay, we're going to use that same broken line graph to answer part B and C. During which month did during which month did the store sell the fewest snow shovels in 2011? Okay, this is 2011 again. The fewest snow shovels were sold during the month of March. Okay, usually because it's the month where spring happens, so here that's why they sold fewer snow shovels. So here during the month of March would be the month that the store sold fewer snow shovels. Now part C, which year, 2010 or 2011, seems to have had the most snow in the store's locale, and why? Okay. By looking at this, I'm going to say the year 2011. And the reason for that, because the store sold more snow shovels like 4 out of those 5 months. Like in November of 2011, they sold more than the same month last year into 2010. In January, it's the same. In February, it's the same. And March, it's the same. Those months where that store sold more snow shovels in 2011 than they did at those same months in 2010. So in this case, that answer choice would be C. Okay. So that's how you take a broken line graph or a double broken line graph to answer these types of questions. Okay, problem number 3. Coach Smith kept track of the jumping records for the basketball team for a 10-year period. Draw a line graph for the data. And this is the data for year and the record in inches. Now, by looking at the record in inches, I can see that these numbers are increasing each year. So you want to pick the line graph that looks like it's increasing year by year. In this case, it would be answer A. Okay, because if you look at your data for the record in inches, each year the record, the jumping record increases. So you can see here that this broken line graph is increasing from 2003 up to 2012. Problem number 4. If a trend line had the equation y is equal to 3x plus 2, what y value would you expect to obtain when x has the following values? Okay, so here the trend line had this equation, y is equal to 3x plus 2. And you want to find out what the expected value is going to be when x is equal to negative 2. Well, here when x is equal to negative 2, then that means y is equal to 3 times. You just replace your x with negative 2, so it'll be 3 times negative 2 plus 2. 3 times negative 2 is negative 6. Negative 6 plus 2 would be negative 4. So when x is negative 2, y is going to be negative 4. And then part B, x is equal to 14. When an x is equal to 14, you're just going to do y is equal to 3 times 14 plus 2. So 3 times 14 is 42. 42 plus 2 would be 44. So when x is 14, y is 44. And then part C, x is equal to 0, means that you have y is equal to 3 times 0 plus 2. Well, 3 times 0 is 0, so 0 plus 2 would give us 2. So when x is equal to 0, y is equal to 2. And finally, when x is equal to 2, that means you're going to have y is equal to 3 multiplied by 2 plus 2. 3 times 2 will give you 6. 6 plus 2 is 8. So if x is 2, y is equal to 8. Okay. So that's how we use the equation of a trend line to find out what the expected y value will be when you're given an x value. Problem number 5. Use the following data to draw a line graph. Use the graph to see what might be determined about the temperature in degrees Fahrenheit of a patient in a clinic. Okay, notice here we got the time and the temperature. Notice here the temperature starts from 96.5 and it does increase up to 101 plus 0.7. Okay, now here from 99.7 it does drop down to a bit to 99.4 and then goes back up. So here you want to pick which one of these will follow that particular pattern. And in this case, it will be answer B. Okay. All right, any question? Well, next question is, what might be determined about the temperature of the patient in the clinic? Okay. And in this case, by looking at this, you can see that the temperature of this patient has been steadily rising all morning long. So that means that the patient is likely getting worse. So here we'll choose answer A. As you can see from this line graph, or this broken line graph, you can see that his temperature is increasing throughout each hour of the morning. So looks like his condition is getting worse. Problem number 6. Okay, This one deals with okay. Now this one deals with association, whether you have no association, a positive association, or a negative association. So in this particular problem, which type of association exists for the data? And is there an identifiable trend? If so, sketch it. In this case, you'll just pick out which one is the identifiable trend. In part A, you see this particular scatter plot. Notice that these data values are going up as your X values increase. So here, this will have a positive association. Okay. So part A has a positive association. Okay. Now, the other part of the question is this. Is there an identifiable trend? And there is, because it has a positive association. So in this case, we want to figure out which one of these has the trend line going upward from left to right. In this case, it would be answer A. And we want to choose the one that would best fit this graph. Now, part C, answer C might be it, but that trend line is not the best fit. This one is a better fit for those data points, so it would be answer A. Okay, now part B, what type of association, if any, exists for the data? So let me go back to part B. Here's the graph right here. By looking at this, I don't see any type of association. Those points are pretty much scattered all over the place. So in this case here, we can say that there is no association. And is there an identifiable trend? Okay. Now this is the choices that you'll select. If there's no association, then that means that there is no identifiable trend. So we choose that particular answer. There is no identifiable trend. Okay. And finally, problem number 7. Again, we revisit the trend line. This time you have y is equal to 2x minus 3. And we want to find out what y value would you expect to obtain when x has the following values. So in part A, you have x is equal to negative 3. So we just replace the x with negative 3 in our trend line equation. So you have y is equal to 2 times negative 3 minus 3. 2 times negative 3 is negative 6. Negative 6 minus 3 is negative 9. Then part B. So for part A, when x is negative 3, y is negative 9. Now part B, here x is equal to 12. So now y is equal to 2 times 12 minus 3. Okay, that's a 2 right here. So that's 2 times 12 minus 3. So 2 times 12 is 24. 24 minus 3 is 21. So y is equal to 21. And part C, when x is equal to 0, that's going to be y is equal to 2 times 0 minus 3. So 2 times 0 is 0 minus 3, which will be negative 3. So y is equal to negative 3. And then for x is equal to 3, you're going to have y is equal to 2 times 3 minus 3. So 2 times 3 is 6 minus 3, which is going to be equal to 3. Okay, so when x is 12, y is 21. X is 0, y is equal to negative 3. And when x is 3, y is equal to 3. Okay, so this should assist you with some of the homework problems in section 10.3.